Okay, well, this is the first attempt at teaching you online. We'll see how this works. Hopefully it goes well. Today is Tuesday. You are going to have assignments and videos on Schoology. Next week we'll hopefully have video conferencing. And we'll talk more about that later. But let's get into this lesson because I want to keep these videos short. We're going to be talking today about chemical bonding. In fact, that is the topic for the next, until the end of next week, at least. When we talk about the word bond is something which holds things together. If you think of the word bondage, if you think of somebody being in bondage, it means something's holding them together. Atoms have to be able to join with other atoms, and those, what holds the atoms together, are called chemical bonds. So a bond is something that holds objects together. Could be a person. And a chemical bond holds atoms together to form compounds or ions. Okay. So that would be a chemical bond, and that will be asked, what is a chemical bond? And that would be the answer. Now, we measure a chemical bond. We call it the strength of the chemical bond, and that is how much energy it takes for you to pull apart that bond. So if I have atom A and atom B, and I have a bond holding them together, and I pull on it and that snaps really easily, we would say that's a weak chemical bond. But if I have to put a lot of energy into it and then finally it snaps, that would be a strong chemical bond. So you're going to be asked about that bond energy. We measure the strength of a chemical bond with bond energy. And that would be how much energy does it take to break the bond. Okay. So that's kind of an introduction to the word bond, chemical bond, and then how we measure it, which would be with bond energy. I realize I keep walking off the screen. I also realize I have to turn my back to you at some point, but I'll be talking. When I do that, it's really no different than being in class at that level. So let's talk about the different types of bonds. There are 3 different types of bonds because there are different types of atoms, or types of chemical bonds. The first type of chemical bond is called an ionic bond. And as you can imagine, it forms between ions. The second type is called a covalent bond. And the third is a metallic bond. Ionic bonds primarily form between metals and nonmetals. That's what they form between, metals and nonmetals. Covalent bonds tend to form between nonmetals, and metallic bonds form between metals. Because of the constraints of this class, we're not going to really deal with metallic bonds. I actually wish I could, but I don't think that's going to happen. We're going to stick with ionic bonds and covalent bonds. So let me I'll just move this. Let me talk about those two. The ionic bond, we've actually dealt with that in the past, but you may not have known it. The ionic bond, you can see the word ion in here. And what is going to happen is the bond will form between a positive ion and a negative ion. And therefore we call it a ionic bond. It forms between the two ions. Just a second, I need to make sure my computer stays on here. Oops, okay, well, we'll just watch it. So an example of this would be if I had sodium and chlorine. And as we've talked about, if we looked at the dot diagram, sodium has 1 dot, chlorine has 7. Sodium actually wants to go back to 0 or 8, the previous one. Chlorine wants 8. This electron transfers over to here. Sodium becomes a positive charge, chlorine is negative, and boom, a bond forms between there. And by the way, a very strong bond. Sodium chloride, you would have to get the temperature, for instance, up to several thousand degrees. I think it's 1,500 degrees before you would be able to break that bond. You'd have to put that much energy in. You're going to melt your frying pan if you wanted to melt salt before you'll melt the salt. Ionic bonds tend to be very, very strong. And that's how they form between a positive and a negative ion. Covalent bonds form by sharing. I should put it, bonds form by sharing of electrons. Okay. This is actually kind of cool, so let me show you what will happen. Let's say we have chlorine that has 7, and there is another chlorine over here that has 7. And you should know that chlorine is a Brinkelhoff. It forms a little molecule, Cl2. Well, how does it do that? You say, oh, well, it'll do it like the ionic bond. This electron will move over here, but then what that would do is leave this one with 6 and this with 8. And that's not going to work. You could do it the other way, but here's what's going to happen. These two will join together. And what we'll end up getting, and you know what I should have done is done a different color here so you could kind of see it. So I'll use green on this one. What you're going to have is this, and then that other chlorine. And we say that this right here is a shared pair of electrons. Now we'll do some of that later. You don't really need to understand that at this point, but what's happening in a sense is they are sharing an electron. So the electron that they're sharing is actually being shared equally among them. And we think of it as something like that, where the electron is in both places, and that electron being shared is the glue that holds them together. Now, there are actually two different types of covalent bonding. There's a covalent bond that is called just that, covalent bond. And just a second, I want to check something. And there's a type of bond which is called a polar covalent bond. So there's actually two different types of covalent bonds. Polar, covalent, and covalent. And here is the difference. It's actually really simple. On a covalent bond, we have equal sharing of the shared electron. Or it could be more than one electron or electrons. On polar covalent, we have unequal sharing. of the shared electrons. Okay. So with ionic bond, transfer of electrons, and that's actually, I should have put that down. Ionic bond is formed by transfer. One gains, one loses. Transfer of electrons. Covalent bond is formed by sharing of electrons. A covalent bond is equal sharing, whereas, the book calls it covalent. I actually like non-polar covalent, but they're just going to say covalent is equal sharing. Polar covalent is unequal sharing. The word valent here comes from our word valence. It's the outer electron. So let me try real quick, because I don't want this video to go too long, to talk to you about the covalent bond and the polar covalent bond, and just try and draw an analogy. And like I said, we're not going to actually do the metallic bonds. Maybe when you come back, we can look at that. We actually had a really cool lab we would have done this week with metallic bonds, but we won't be able to do that, of course. If I take chlorine and chlorine, and if you just think about this, both chlorines are identical as far as we know in every way. So this chlorine wants that electron, and this chlorine wants that electron, and this chlorine wants that one. And together, they will end up sharing, and these two are shared perfectly equally. So basically, this atom, chlorine, is trying to attract this electron with as much force as this one. It's like a tug of war between them. But if I had hydrogen and chlorine, what you will find, and we'll talk about this in the next section, is that this chlorine, and you know what, maybe we should use instead of, yeah, we'll do this. If we had this, hydrogen actually has just one, but it wants two because it's going to fill up its outer shell with just two. Chlorine has a much stronger pull on this electron. And so what we find happening is, although we're going to draw this the same way, remember, hydrogen always wants 2 electrons, the chlorine wants 8. This is our shared pair of electrons. What we're going to have, if we were to map this out, is that this shared electron spends most of its time over here with chlorine. This will be the topic for tomorrow's lesson. But what happens is this side of the molecule is more negative because the electron is here more often. The electron is more often on this side. Whereas this side is more positive because the electron isn't over here quite as often. So this would be called covalent, or that's where your book will say, but I would call this non-polar covalent, and this one would be polar covalent. So let me just make a comment about a word. The word polar actually means opposite ends. If we talk about people being polar opposites, they're as far apart as they can be. On the Earth, we have the North and the South Pole. They're as far apart as they can be. If we have an issue in our country, like abortion, we call that a polarizing issue because people are on one side of it or the other. They don't tend to be on both sides. There's a much common ground between them, is what I should say. So let me end by just giving you an analogy between the different types of bonds. An ionic bond is real simple. It's like a transaction. If I go to the store and I want a Coke, and because I'm thirsty, and the store owner has the Coke, but he wants the money, I give him money and he gives me the Coke. That's an ionic bond. A covalent bond is when you have to share to accomplish your goal. So let's say you and a friend of yours, and it's Fresno, and it's 105 outside, and you decide to go for a walk. You start walking along and you get thirsty and you see a Coke machine. You walk up to the Coke machine and you have 50 cents and your friend has 50 cents and it costs $1. Neither of you can get a Coke on your own. But if you pool the money, you can buy one Coke and you can share it between the two of you. On the other hand, that would be a covalent bond, perfectly equal sharing. We both put in the same money, we both get as much Coke. You get half, I get half. But imagine that we had a situation where, same thing, we're out walking, we're both thirsty, and we get to the Coke machine, and I reach in my pocket and I've got 75 cents, and you reach in your pocket and you have 25 cents. Can we get a Coke? Well, yes, we can. But I put in 3 times as much money. So I'm going to say I get more of the Coke because I'm like that. I'm kind of selfish. I get the Coke. I get 3 sips and you get 1 sip. I get 3 sips and you get 1 sip. That's what's happening here. Chlorine is selfish. It says, I want that more than you do. I'm going to take it more, and that electron ends up over here. So if you go watch this video and then you go on to look under the folder, there is a short little assignment for 11.1. It's very simple. Read the book, do those problems, submit it, and that's how I'm going to grade you in the course, is whether you're watching these videos and doing the assignments. So hopefully this works out well and it uploads and everything's good. 16 minutes, that's what I'm going to try and keep them to, is just about 15. So, all right. Hopefully we see you soon and we don't have to do tons of these, but if we do, this is the way it's going to work, I hope. All right. Talk to you later.